So this is quick and dirty data analysis. This is quick and dirty time series analysis with Clojure and Encounter. So hi, I'm Bruce. Nice to meet everybody. I'm out from, I have a startup, Mastodon C. I want you guys to all, so Datomic, stop running Datomic. Have you seen it? Look at that. You can't see that? Could you see the map of the world? Big map of the world here? That's Virginia. That's US East. Don't run it there anymore. Look at it. It's terrible. It's terrible. 339 kilograms CO2. Definitely run it. Look at how wonderful. Oregon is beautiful. Still in the US, so it's great. Run it there. We'll do live coding later. So that's me. Marco introduced me about working with the London Clojurians. I didn't start it, but I picked it up and ran with it along with some other people, Robert definitely being around the longest. So, time series analysis with Encounter. Step 0, what do you want to do? So you've got all this data lying around and you say, oh, we need to do something with it. What's the first thing you need to do? You've got log files and you've got databases and the APIs and you have no idea what to do. Am I doing enough jazz hands? Jen, am I doing enough jazz hands? Yes? Okay, enough jazz hands. Good. Jazz hands are important. The slack part of the day, you're already falling asleep while I talk about statistics. So you have all these things, log files, databases, APIs. They all have lovely events in them that you've been storing as you've been going along. Now, one of the other things that's really important when you're doing stuff like this is in addition to looking at the data you have and looking at the sources you have, is you need to talk to the people who are out there and say, well, what is it that's actually important? What's important in our business? Is what's important, what percentage is our CPUs running out? Is that the most important thing? And how many people work in some sort of business and get paid to code? Yeah, there was a, I pretty much knew that one. So is the most important thing in your business CPU utilization? Is the most important thing, really? Wow. What business is that? Do you heat rooms with CPUs? So you want to keep the CPUs nice and hot? All right, okay, right. So, or how much disk utilization or stuff like that. So with the time series stuff I'm looking at today, we've been looking at a lot of other things with Raymond and with other systems where the time series stuff, it's like if it reaches a threshold, either too high or too low, you can alert. So today I'm going to talk about slightly different time series stuff. So step 1, when you have all these things, the first thing you're going to do with them is you're going to do ETL. This is going to take longer than you think. Now, for your ETL piece, now when I say ETL, I know ETL is a dirty word, but stuff like that. But you have all this stuff in log files, you have all this stuff all over the place, and you haven't been smart enough to put it in Datomic from day one when you started your business 15 years ago because Rich hasn't invented the time machine yet. It's the next project after Datomic to actually make Datomic go in the past, to get all your data in the past, because that's what you're hinting at with time and value and all that about going, yeah, I knew it, I had you. So you might have data in a lot of other places. So if your data is really big, you might be saying, oh, I want to use Hadoop, because Hadoop's the new cool hotness and stuff like that. So no, I mean like really, really big. If your data isn't in, tens of gigabytes, terabyte scale, if it isn't that, use Clojure, Hadoop, Cascalog. Cascalog looks really cool, and actually I would rip out all this ETL stuff that I would do other ways and actually probably use Cascalog or maybe Datalog to do all that stuff to transform the data into what I want. And so she'll probably rip out about half my presentation, but I didn't have time, and I was too busy drinking last night with everybody, which was fun. So if it's gigabytes or lower, just do it. Just use Clojure, get it the data, transform it, put it someplace else, put it in intermediate things you're going to calculate on later. So the way you do this in Encounter, there's a package called encounter.io, and it has read dataset, and I'm just going to go through this. So, right. Live coding time. Dun, 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 dun. Dun, 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 dun. Right, can everybody see that? Right, Pingles can see it. Who can't see that? Right, nobody can't see that. Everyone can see that. That's easier, isn't it? That's not going to work. Right. So what I have here is I have lovely CLJ time, because I want some time format stuff, because I'm doing time series stuff, and the CLJ time package is really, really good for that. I've got CLJ time core, which is where I've got my core stuff. So time format is so I can go from time strings into time objects. Time core has all my time objects in it. Time coerce allows me to go from time objects to milliseconds. Every time you want to deal with time series stuff, everything that graphs or charts to deal with time series stuff says, oh, I do milliseconds since the epoch. Does anybody know any time series packages that don't do milliseconds since the epoch as an index on the time field? Come on, there have to be some R hackers out there who've done something with time series and something wacky that doesn't use that. Really? Okay, right, anyways. So then we have Incantor Core. So Incantor Core, that's got all of our basic stuff for manipulating the core data structure in Incantor, which is a data set. There's also a matrix. And a data set is a bit weird in that it's a record that has column headings across the top, and then it has, and then the second thing in the def record is basically a vector of vectors that has all your data in it, which makes it a little bit weird to deal with. Who's used Incantor before? Right. Who's a complete noob today? Right, so about half and half. Who's a mediocre programmer? That's me! Right, so what I like about Incantor is I don't know any stats and I am not a great programmer, and this lets me be dangerous. I can do things with this that I would not be able to do in another language. I would find it too complicated, I would find it too hard, it would break my brain, I couldn't keep it all in my own head. So that's what I like about Clojure, that's what I like about Incantor. So it lets me do stupid things like this. So, Incantor Core has all the stuff for manipulating all the stuff. And Incantor Stat Set has things like mean in it, which we're going to use later. Incantor Charts lets us make pretty pictures. Pretty pictures, I mean, you know, come on, guys, I'm competing with Nick Rothwell here. I mean, come on, you can't really expect pretty pictures out of me after Nick. So, you know, I can make some reasonable-ish charts. And Incantor.io, that's what we're using to read our stuff in. And Clojure REPL, because I might do something like type doc on something like that later, and Slime doesn't have Clojure.REPL in it as standard. So what we have is we have our time series, which is all the beer that has been drunk by Clojurians on a monthly basis, or actually on a daily basis, sorry. So if we have a look at that, using my first contribution to Incantor, which is a head function, which is terribly, terribly inefficient, but somehow snuck in anyway. So we want head on series. So as you can see from that, head gives you the first 10 lists of something. So there are hundreds of things in that, and it'd scroll off the screen and it'd be terrible. So head is one of those nice things from R that allows you to go through and say, right, just show me the beginning of it so I can get an idea. So as you can see, what we have here is we have dates and pints of beer drunk. So on the 1st of January 2011, Clojurians drank 6,673 pints of beer. And I'll have you know, these are just London Clojurians. There are 250-ish of us on the list, and that's what I consider to be the group of London Clojurians. So that's, see, here we go. We're doing the really big live coding now. You ready? This bit, not planned. You ready? Ready? Is it gonna work? Wow, 26 pints of beer a night? And that's a low night. Right then, so that's our data set. So now what we want to do is the problem is that date, that's rubbish. That's a string. Can't do anything with a string. So what we need to do is we need to turn that into, we need to use tformat parse. So this is from CLJ time format. And it has a whole bunch of keywords that have standard ways of parsing things for it that'll probably do most of the things you want unless you have particularly wacky dates. So we're doing year, month, day. And we are going to, so here we are using our first bit of core. So Incantor $map. So there's $map is really important. $map goes through each of your things in your lovely data set, and just like map, apply something onto each of the elements in your thing, and it's terribly complex, and it's horrible, and it's awful, and I'm surprised you don't complain about it more, Reg. Is Incantor okay? Do we survive? Can we keep Incantor for a while? Sure? For a while anyway. Okay. So for a while anyway. I try not to look at Rich. He scares me. So anyways, so what we're going to do is we're going to do a map over the date column. So it's $map. Apply this function over that column for that particular data set. And then if we have a look at that, so now this is one of the weird things about Incantor is if you have a data set that only has one column in it, it actually comes back as a sequence rather than coming back as a data set as the other things do. So as you can see here, you have a sequence of date-time objects, and they're all at midnight, which is nice because we're just dealing with days. So then what we also want to do, now that we have that, is we actually want to turn those into milliseconds because everything else we're dealing with deals in milliseconds. So again, we're using Incantor.map to go through, and we're using coerce too long, so this is going to turn it into milliseconds since epoch for each one of our data objects over the DTS column in the time series I just did. So that is going to give us, and Robert, I'm sorry, my variable names are too short for Robert. He's going to come and punch me in a second. So that's giving us milliseconds since epoch, so that very large number there that doesn't have any commas in it, so I can't read it that quickly because I don't know, because I can't. So what we want to do now is we want to use our next function from Incantor Core. So we've used $map from Incantor Core, which is really important. This is after using read dataset from Incantor.io. We've converted strings using CLJ time format into date objects, and we've used coerce to turn date objects into milliseconds since epoch. And so now what we want to do is we have, as you can see, we've got our original time series, which has the 2 columns in it, which is nice. And now we have these 2 sequences just floating around, but each one of those sequences is in order, and they're the same length as our original things. So what we're going to do now is we're going to stick them all together into one big data set, and we're going to do that using conj calls, which is our thing here. So we're going to conj calls the original series, the datetime objects we did, and the timestamps. So we've got them all together. And then we'll have a quick look at that. So, right, there we go. Date, beer, date timestamp, which is our object, and milliseconds since epoch. So now we can actually start to do some stuff with that. So now we can actually start doing some fun stuff. So if you don't like looking at it there, Incantor Core also has a view, and that gives you a nice graphical viewer, which is, I don't know if you have people who are afraid of text. I suppose it lines up the columns nicely with everything. So what we want to do now, so we don't want to add day of week to now. See, there's me skipping ahead. So what we want to do now is, so the thing is all the other things we've been dealing about, I mean, we've had exponentially decaying rolling means, and roll means are really cool. Do people, who doesn't understand roll means? Okay, right. So what a rolling mean is, a rolling mean says, so tell me what the mean is, not over the entirety of the time, over the entirety of my series, but just over the last period. So give me a rolling mean of a particular number for the last hour. So that's really, really handy because, you know, if you do, say, from the start of your business to now and you get the mean from there, the start of your business for the first 3 months you didn't sell anything, which I'm trying not to panic about as I start my own business, to, you know, selling everything in the world and making loads of money. So your mean doesn't really make sense over there. So rolling means are great. This is nicely in the middle of our beer data set. We've been drinking beer for a long time. So if we just look at the mean for that, you can see the mean pints of beer drunk per day is 8,922 and a bit. I think we could probably do a ceiling on that and probably call it 8,923 pints on average drunk, unless somebody's sort of leaving theirs through their cigarette end or something like that and didn't finish it off. So, what you want to be able to do with your data, once you have it, so it's like, okay, right, I've got my data in, I've looked at my data, we know we want to talk about beer because we're in London and London is all about drinking, so we're looking at beer all the time. So once we have our beer and we've looked at it there and we've said, right, well, we know what the mean is, but do people think mean probably makes sense for this data set? Who thinks mean makes sense for this data set as an average thing? Who thinks mean doesn't make sense? Okay, so a little bit more for the doesn't make sense. So what we want to do is we want to graph this. So what I've done here is I've got just a lovely little function that is just wrapping up some things. So this is one of the things I discovered. I don't know how many of you saw me complaining about Twitter between trying to do CSS and trying to do this, because you do an awful lot of typing when you try to make things into pretty graphics. Text takes a lot less typing. So what we're going to do here is we're going to do a time series plot, which is why we have the milliseconds. Milliseconds are good. And across our x-axis, we're going to have date. On the y-axis, we're going to have pints of beer. We're going to have a legend on it, and it's going to be pints over time. And in this lovely function, I made it so you can pass in a theme, and Encanter comes with 2 themes, light and dark. This is very exciting like that, which comes out of the JFreeChart library. So our current data set is TS1. So if we look at, it's S1 rather, and we want to do that dark. If we look at that, and then what we want to do is, so the thing is, so right, here's one of the things that's going to throw you off when you do Encanter the first time is you go, oh, right, so I want to do a plot, that's great. And you do that, and it goes, great, I got a great JFreeChart. And you look at it, and you go, where'd my JFreeChart go? And that's because what you have is you have a JFreeChart object that you then need to view. So there we go. Right. So there's our stuff. So those of you who said, so now the thing you want to do when you want to look at a chart like this is there are a number of things you want to pay attention to. This is why graphing things is so important whenever you're doing stats. Don't say, I know what I'm going to do. I'm going to throw every machine learning thing I can possibly do at something, when actually you can probably get away with getting most of the information, at least as a human, just by doing some relatively simple stats on something. So don't break out the machine learning tools yet until you actually graph it and look at it. So what can we tell about this? What's important about this? One thing, it's flat. I can draw a line through here. I can go back the other way. The other thing, does that look like a cycle to you guys? Cycling, yeah. So it might be going down a little bit. It's certainly not growing. It's not a hockey stick. We're not talking about exponential growth here. We're not even, you know, if we were to draw a line with that using a linear model, do a bit of regression, which you see, the problem is every time I say regression, I go, oh, that's stats. I get scared. I can do means, and the thing is, you can look at a chart like this, and you can probably get enough of an idea to know whether or not you need to be particularly clever when you're doing something with stats. So the nice thing about this is going through all of our points. There's nothing out there, you know, the scale fits rather nicely. There's nothing that's way out there. So we don't need to worry about dealing with any massive outliers of things that are way out there that we need to take care of. We've got cycle, so we need to deal with the cycle. So that's the important thing with this. And we don't need to deal with growth. So that's really nice. That makes a lot of things a lot easier. So if we're going to deal with cycle, then one of the things we probably want to do, so actually if we go and look at that. So the problem is when we look at that cycle, let's go and do the next one anyway. Let's go and make S2. So what we do is we go and calculate the days of the week for everything. So that's what this is doing. So that's using time, day of week. So that's taking each one of our time points and saying, right, that's day 0, day 1, day 2, day 3, day 4, day 5. And this is a point at which I always then have to go, I can never remember which day is which. So I have to do time, day of week, and that's not terribly legible. So Monday is 1 and Sunday is 7. Can you guys see Monday is 1, Sunday is 7? Okay, if you can't see it, take my word for it. Monday is 1, Sunday is 7. I'll not do too many documentations because the contrast on text like that isn't so great on here. So we calculate the days of the week, and then what we do is we conj that days of the week. So days of the week is going to look like I don't want to half vectorize it. I don't even know what that does. So days a week, 6, 7, blah, 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 blah. So that's our head for days a week. So what we want to do is we want to then conj that onto the rest. So that's given us S2. So as you can see now, we have days a week on the end. So we have 6, 7, 1, 2, 3, 4. So we're all nicely in order there, which is good. So now what we probably want to do from there is what we want is it'd be really handy to just look at 1 month to get an idea of what kind of cycle this might be. So what I'm doing here, so we've looked at days of the week, we've looked at some CLJ time stuff, so now we're using $where in Incantor Core. So $where allows us to pass in a map that allows us to query the data sets we have. And so we're saying query the milliseconds column and get me the things where it's greater to or equal to coerce to long, and then we're creating a new time date because it was just easier that way because I couldn't remember what the milliseconds was for the 1st of April, but I could write out date time for 1st of April, and then coerce that along to milliseconds because it's a lot faster comparing millisecond integers than it is comparing date time objects. So for larger data sets, so it's a nice little bit of premature optimization that I remember from the last times I optimized these things late and realized I needed to actually present it in front of other people rather than wait for it to grind through. So that is going to give us just the month of April from the 1st of April to the 30th of April. And so now if we go back and if we graph it again, but this time instead of with time series 1, with time series 2, which is what we created. And don't worry, Robert, we're not going to turn this REPL into something that then needs to be maintained by somebody else without having much better names. So, that's not what we wanted. That's because it's S2, and I don't want S2, I want April 1 basic. Right, that's a lot clearer. So, counting from the low point, 1, 2, 3, 4, 5, 6, 7. That looks like a weekly cycle to me. Weekly cycle? Yeah? Okay, so the nice thing is, we've got a weekly cycle. So for that particular month, April is going down, but we saw for the overall data set that it's probably flat. We know now that we have a weekly cycle, so now what we want to do is we say, right, we've got a weekly cycle, so we know. So let's just presume at the moment that that's a Monday. Actually, I think that's a Monday. Let's presume that's a Monday. Does anybody know what date that is? So let's presume that's a Monday. So the thing is we know that a Monday, Tuesday, Wednesday, so a Monday and Wednesday, so the Mondays are here. So for an average for this, a good Monday is going to be somewhere around here. But Monday, Tuesday, Wednesday, if we had a good Monday number, so if we had 7,500 on a Monday, that'd be an okay Monday. 7,500 on a Wednesday is an absolute disaster. We don't want that. We don't want disasters. I don't want disasters. Is anybody, who wants disasters? Okay, right. So the hecklers want disasters. You guys are real pals. So what we're going to do now is we're going to use another nice little bit of Incantor, and it is going to be the seasonal means. And the way you do a seasonal mean, so what we have here is we have our seasonal means, and we have how we generated the seasonal means. And how we generated the seasonal means is we said encounter dollar roll up. And what dollar roll up does is it says take a function, in which, in this case, so we saw stats mean for reflection here before, so what we're doing now is we're using it on stuff that's rolled up. And what we're doing is we're rolling up the number of pints of beer drunk per day by the day of the week over our S2, which is the series we're working on. So what that does is that gives us this. So here's our days of the week. Tick, 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 tick. And here's the average number of beers drunk per each one of those days. And I can't do things like that. I get terribly confused when I see things like that because I can't reorder them in my head. So here they are in order. I can't even remember. So what's day one? Day one's Monday, isn't it? So day one's Monday. Monday, we drink 10,000 pints of beer because we're really sad to be at work again, and we often have meetups on Monday, so we drink a lot on Monday. And Tuesday, when we have the dojos, we actually drink a lot of beer again. So you know, I've had this before. The people insisted the 1 and 2 were Friday and Saturday. I don't think that's true. The first and fifth. Oh, the first and fifth. Oh, thank you. So we drink very little beer on Fridays, but we drink loads of beer on Monday and Tuesday. A fair amount of beer on Wednesday, and then trailing down. And then Saturday and Sunday we drink fewer pints of beer because we're probably recovering from the Monday and getting ready for Monday again. So what we then want to do is we want to, let's see, what are we doing next? So, I don't want to do that next. I want to do that next. Right, so what I want to do now is I want to join our seasonal means onto what we had before. So we do that using our next bit of encounter magic, which is $join. And what $join takes is it takes these two keys here and says join on those two keys. So this is our season column, which in our initial data set we called day of week. Probably should have called them both the same, but then at least you can see that there are two different columns for two different things. And then we have which data sets we're joining. So it's SM-SD and S2, which we're joining together. Oh, that's why. I need to actually generate SMSD. Right. So what is that doing? So let me remind myself what that's doing. So here's me not using threading. Or not using the threading macro anyway, though I don't think I can use the threading macro here. So what I'm doing is I'm getting the standard deviation. So stats SD is standard deviation. So who knows what standard deviation is? Right, who doesn't know what standard deviation is? Okay, right, can somebody explain standard deviation to me, please? Because like I said, I don't know stats, but this allows me to be dangerous. I know the standard deviation is, basically when you draw a nice bell curve, if your data is normally distributed, which is to make Elise happy wherever you are out there. So if your data is normally distributed, basically standard deviation is basically the quartiles moving out. How far out is one standard deviation from the mean? How much does that cover? 4 standard deviations covers 99%. How much does one standard deviation cover? Is it just, Close enough for me, a lot. And enough for what we're doing, because a lot of what this is that you can say, right, you know, there are all these maths and there are all these things, but what we're going to get to is we're going to get to what is actually the useful bit that actually lets us know when something has gone wrong. So what I'm doing here is I'm actually calculating the standard deviation for the whole thing, and then what I'm doing is I'm creating a high and a low for each one. So what am I doing there? So standard SMR. Right, so what I'm doing here is I'm actually creating, let's have a look at it. And then I can actually stop reasoning it out and I can actually just think about it, look at it. Sorry, it's starting to get a little bit long. Can people still see that? Can you see that in the back? Yep, right. So what we've done is we've calculated standard deviation high and low. So one standard deviation. So basically taking our seasonal mean and saying, right, what's one standard deviation above, what's one standard deviation below, and then we've done 2 times standard deviation above and 2 times standard deviation below. So that gives us some bounds in which we're interested in, because what we want to be able to do is we want to be able to look at that cyclic chart, and similar to a lot of the other things where we've talked about alerting, we want to say, right, so when is it not normal anymore? When have things gone wrong? And the problem is you can't just do a straight mean and just do standard deviation across the mean of the whole thing. You have to do standard deviation against the seasonal mean to figure out whether or not you've gone wrong for a Monday. So what we want to do now, so after that roll up, so basically anytime you roll something up and you then say, right, now I want to use this with the rest of the data, if you do a dollar roll up, you're probably going to do a dollar join. So we're joining S3, so, which we actually did before. So if we have a look at that, and this is going to be huge. That's because there isn't an S3, because it's head. That's even longer, but basically you can see here, so what we have is we have date, milliseconds, the mean, date timestamp, 2 times standard deviation low, beer, and it's gotten terribly out of order. But so we've got beer, 2 times standard deviation high, low, day of the week, and so we've got all sorts of things in there, which is great, which is all the stuff that we've all joined together. And then what we want to be able to do is we now want to be able to add a column onto it. So we've got this column that says, right, so each date has the seasonal means for that day of week against that date, and it has standard deviation high and standard deviation low. So what we want to do is for each thing that is now breached over 1 standard deviation for that day off the seasonal mean, we want to say that's too high. We're far too drunk that day compared to how we normally are. And everything that has gone below 1 standard deviation for that seasonal mean, we said, clearly we've run out of beer, because if we had more beer, we probably would have drunk more that day. And we want to avoid low beer days. So if we do a head on S alerts, so you can see there for the alert, certainly for that first section, there's nothing there, they're all 0, so we're not alerting on any of that. So we were looking at April before, so let's look at April again, but this time let's look at April with our alerting series. So this is a bit where it really gets to be a lot of typing. So we've got this alert chart, and with the alert chart, what we want to be able to do is we want to be able to and relax. It's the coughing threw me off. So what we want to do is this is very similar to the last one we did. It takes in a time series and a theme, but this time our time series is going to have a lot more data in it, or a lot more columns in it. So we're doing a time series plot, and we're charting milliseconds against beer, and our data is the time series passed in, and the X label is the date, the Y label is pints of beer, the series label is pints over time, and we're going to add a legend to it, and we're going to set the theme based on the theme passed in. And now what we're going to do is we're going to add lines. So the lines we're adding in, we're going to call low threshold, and that's going to be, so this dollar is a select, and what select does is select chooses a column out of an encounter data set. So what we've said is, so add lines, and then what add lines takes is it needs an X and a Y, and on a time series chart, that X and the Y, the X needs to be the milliseconds, and the Y is whatever we're trying to measure on the Y-axis. And so for here, it's going to be milliseconds across the bottom, and then it's going to be standard deviation low, and we're going to call that the low threshold, and then we're going to add lines again, and we're going to do the one-time standard deviation high, and we're going to call that the high threshold. And then what we're going to do is we're going to add points to it as well, because we have these alerts where things go 1, 0, -1. So we've got alerts where things are too high or things are too low. And so what we're going to do is we're going to add some points to it, and we're only interested in the low alerts, because if we get too drunk, it was probably a really good party, so that's fine, because we like good parties. So we want to alert on the low beer days, because we want to go back and we want to investigate that, and we want to say, because, I mean, again, this comes back to the human problem. I've talked about lots of stats, but, I mean, what's the important thing here? Does anybody know what the important thing is in all the stuff we're talking about? Beer. So at some point, some organizer in the London Closurians screwed up. Oh. At some point, somebody delegated by an organizer in the London Closurians screwed up and didn't produce enough beer for the evening. And we need to investigate those things. And we don't want to do blame, but clearly we want to find the culprits and suitably, what's the word I'm looking for? It's not punish, but it means punish, but it's sort of like, it's more agile, more fluffy. So can any thought workers help me out, or anybody from Forward? So what's the fluffy term you use when you want to punish somebody so they don't do something again, but you still want to make it happen again? You want to make them feel bad for it? Crucify, yes, yes, that's the agile term, crucify, thank you. So we want to find the people who were responsible for the low beer and crucify them. So the other thing is because this is a great, big, horrible projector, and this is part of the reason why I'm live coding it, is I had to play a lot with the stroke colors, because the standard stroke colors, I mean, they look a bit rubbish anyway, but it's even worse when you're trying to do it on a great big screen with terrible resolution and even worse contrast. So I've made the stroke for dataset 0, so that's our main dataset. I've made it nice and fat. I've given it a width of 5, and I've set the stroke color, which unfortunately, oh, you can see it a bit better there, so I've made the stroke color yellow for dataset 0. For the high threshold, I've made the stroke width 5, so this is for dataset 1 for the high threshold. And I've put dashes on it because, you know, these are our boundaries. So think of the dashes as sort of a fence that we don't want to cross. Well, actually, the high fence we can cross because that's a good party. But the low fence, the low beer alert, we don't want. We made that green because if we go over the green, green's good, right? Yeah, right. So the low threshold, again, we did the same thing. We make it red because we don't want to go below red. For those of you who in the audience who are colorblind, so if we go above the brown, if we go above the top brown, that's good. If we go below the top brown, that's bad. Brown is still bad, so it's still okay, even though red and green in charts' ways of doing things is really, really bad, and you should use saturation. But it's J-free charts, and there's only so much I can do, and nothing shows up on the screen anyway. So, and then the alerts, for the beer alerts, so we do set stroke on dataset 3, so that's our alerting series, and those are our points where things have gone below -1, or are -1. And so the strokes are actually going to be dots because we did those as dots above here. It's terrible. So the add points is going to add dots, but you still call it a stroke. And so the width is 10. Now the thing is, doing the width 10 doesn't seem to make that much of a difference to the size of the dots, which is really annoying. And I should look at the code on that and probably fix it. And we've made the color red because red's going to be very dramatic. So we go and evaluate that. And then we go and evaluate the whole thing, and that's what the whole thing looks like, and you guys all completely understand that, don't you? You go, yes. You can't see a thing on there, so that's terrible. So that's rubbish. So what we want to be able to do is we want to say, okay, right. Is there anything I see? So April, there are dots in April. April was a disaster. It's almost as if I knew that we were going to look at April at the beginning because I knew April was a disaster, like I'd prepared this before. Nobody actually thinks I prepared this before, though, did you? You all know this is completely extemporaneous. Nothing could be this ropey and be prepared, right? Right, so I've executed that, Control-X, Control-E, using a bit of Emacs magic. I've avoided Robert's curse so far. I've gotten to my last line of code. So here we go. Right. Who organized those? Red dots. Nice green dotted line, we've gone below that. See, the thing is, we get really close to this. I mean, you know, there. That close to disaster. we didn't have a disaster that day. We were sufficiently drunk that day for what we are normally. At no point did we get too drunk. April, it's April. You know, we're not going to get too drunk, so we didn't have too many parties. But at some point, we did not have enough beer. Actually, at 1, 2, 3, 4, 5, 6, 7, 8, 9 days, not enough beer in April. So I think the important thing, and that we can all conclude from this, is that even a schlub like me, who doesn't know a lot about Clojure and is just a mediocre coder and knows absolutely nothing about stats, because, okay, so for even those of us who don't understand stats, which includes me, I understand simple averages. I understand means. So a mean is when you say, right, add up all the numbers, and so if I've got 10 numbers and then divide by the number of numbers. Cool, I can understand that. I can do addition and division, and then all I'm doing is I'm saying, right, okay, so I just want to do addition and division for different days. I can cope with that. I can handle that. And the thing is seasonal means and graphing these things is enough to do this alerting series. So that's enough to deal with something really quite complex. So Ryman, does Ryman do seasonal means? Does anybody else's alerting stuff out there do seasonal means out of the box? No? Add it in. It's easy. Even I can do it, and I'm a schlub. So I've gotten through an awful lot of that. So I talked about outliers and means and stuff like that. So high frequency data, when you're dealing with high frequency data, that's one of the things you have to be careful of. This is where your rolling averages come in. So on your daily data, it's fine. Daily data, you don't need to worry about these things, but if you're monitoring things minute by minute, minutes vary too much to be able to say, oh, well, I'll get the average for exactly that minute all the time. And the thing is, now, when we did seasonal means where we said, oh, right, our days are important, days of the week are important. Now, one of the seasons you might look at is you might look at minute per week, because 9:25 a.m. on a Monday, if you have a weekly cycle where you have a daily cycle as well, 9:25 on a Monday is probably going to look very similar to 9:25 on the next Monday, but it's going to look very different to 4 in the afternoon on a Friday. So seasonal means doesn't just mean, spring, summer, autumn, fall, winter, anything like that. It doesn't just mean days of the week, it doesn't mean months. It also means, minutes per day. If you're doing something really, really high frequency, seconds per day. But if you're doing high frequency stuff, you probably do want to use an exponential decaying mean, which hopefully somebody's written for you because it's more maths than I can do. There are some nice things in Cantor.zoo. So Edmund, wave. Edmund Jackson, wave. There you are. Thank you for Encounter.zoo. It was, so you did all the roll apply and all the roll stuff in that, and that's all really good, and that's a good start. And so the nice thing is roll mean, really, really good if you're actually looking at the average. Now, one of the things we didn't have in our stuff is we didn't have anybody who was way up here or way down here. So if you have things that are sort of complete outliers, if you're the LA Galaxy and you have David Beckham on your team and you don't want to then your average salary doesn't matter. Nobody knows who the LA Galaxy is, do they? Right, okay. Basically, if you compare doing salaries, okay, here's one that's topical. If you're doing salaries over everybody in a country, including the salaries of the top 0.1% and including that in the average salary for the country is probably a bad idea, because the top 1% salaries are probably in the billions, or the top 1% worths are probably in the billions, whereas the people in the middle, they're going to have a mean that's much different. So for those, you probably want to look at doing a median, or what you might want to do is you might want to look, if it's a small number of outliers, you might just want to, I wouldn't like to say kill them in your data set. That would probably be bad given the example I just used. But you probably want to remove them from your data set, just from the data set. Just from the data set. And then you might do roll mean after that. But if you don't want to, if you can't remove them from the data set, or there aren't too many, or there aren't too bad, they don't pull things off, then you use roll median. Talked about detrending the data. So the way you detrend the data is through a difference. So this is one of the things we didn't have to do. And basically detrending means I have a sequence of data, and what I want to do is instead of saying A, B, C, D, and actually getting an average on those, I want to say, what's the difference between A and B? What's the difference between B and C? What's the difference between D and E? And going like that. because when data has a trend, when it's going up or going down, the difference in between each one of those is something you can still get an average on. So that makes sense, actually getting the difference between two. So that's how you detrend things. We did a lot about deseasonalizing. That was most of the example. So we did finding the outlier, standard deviation, blah, blah, blah. So these are pretty charts again. So real-time alerts. Raymond? How do you pronounce that again, Sam? Riemann. So Riemann, Nimrod. Where's SP Tourist? Wave. Hello. Beautiful, non-invasive log monitoring. Talk to this man over here. Storm's another example as well. So the kind of things, so what you do is, if you want to do real-time monitoring, so you saw, that chart of, okay, what's our important thing? Even if you're doing, minutes per week, you still aren't talking about that many data points to look up against in a hash. So the thing is you say, right, so I've got this thing I want to monitor. Instead of saying, right, just tell me if I'm, 2 standard deviations away from the mean for the entire data set, that doesn't make sense. But what you can do is you can say, right, tell me if I'm 2, 3, or 4 standard deviations. So that's one of the other things about high frequency data as well, is your standard deviation matters a bit more, and I need to cut it off. So these things are important. Do this stuff. Step 6, do it all again, formulate a hypothesis. And I was going to put a go-to here, but I couldn't bring myself to do it. And thank you very much.